Nikola Tesla The Electric, Sorcerer.
Part 1. Tesla left Philadelphia by rail at the end of February for the National Electric Light Association convention in St. Louis,
Accompanied by T.C. Martin, who was covering both lectures for electrical engineer. They discussed the creation of a textbook based on the inventor's collected writings. The first half would be devoted to the full range of invention circuit with the AC polyphase system, with chapters on motor design, single-phase and polyphase circuits, armatures, and transformers. The second half would contain Tesla's 3 discourses on high-frequency phenomena, which he had presented in New York, London, and Philadelphia, with an introduction written by Martin and a few miscellaneous articles at the end. The treatise would run almost 500 pages.
George Wessler would be second editor.
Publication date was set for the end of the year.
Martin had achieved a great coup, solidifying a deal with what many people were saying was the greatest living electrician.
The inventions, researches, and writings of Nikola Tesla would be a landmark text, becoming a virtual Bible for the numerous electricians who read it.
On February 28th, Tesla arrived in St. Louis, invited to speak by James Iyer, general manager of the local municipal electric light and power company. The arrival of the inventor created a jolt of excitement.
His speech was billed as a replication of the London lecture.
Over 4,000 copies of the journal containing a biographical sketch were sold upon the streets, something unprecedented in the history of electrical journalism. A procession of 80 electrical utility wagons and meter men carts rolled down Main Street as thousands of people clamored to get tickets for the performance. At the opening ceremony, both Tesla and I were inducted into the association as honorary members. 3 afterward, I introduced Tesla to one of his engineers, H.B. Broughton, a recent graduate of Cornell University, who was assigned as an assistant for the duration of the convention. The chamber allocated proved to be too small, so the event was moved to the Grand Music Entertainment Hall, a large auditorium with a seating capacity of over 4,000.
Tickets were hawked on the steps for anywhere from $3 to $5. Yet even this theater proved to be inadequate, for the house was crowded to suffocation.
Mr. Iyer introduced the inventor to the audience with a sort of reverence as one who has an almost magic power over the vast hidden secrets of nature, and presented Tesla with a magnificent floral shield, wrought in white carnations and red beauty roses.
Peering out at the sea of faces, Tesla realized that it would be wise to restrict his lecture to the more spectacular experiments.
With Broughton, he displayed his invention of wireless transmission of electrical energy by lighting up wireless receiving tubes by throwing a switch from the opposite side of the room.
"Of all the many marvelous things we observe," he said, "to me it seems a vacuum tube excited by an electric impulse from a distant source, bursting forth out of the darkness and illuminating the room with its beautiful light, is as lovely a phenomenon as can greet our eyes." By way of amusement, Tesla created sheets of electricity between 2 condenser plates. He illuminated light bulbs with and without filaments, ignited phosphorescent globes that threw a mass dazzling light far beyond that yielded by any ordinary phosphorescence, and created strobe effects by whirling tubes that looked like white spokes of a wheel of glowing moonbeams.
Tesla then approached his most powerful coil, noticing Prof. George Forbes in the audience, the engineer from Glasgow who had so highly recommended his AC system to the Niagara Power Commission. The inventor bowed in respect, acknowledging his appreciation. Tesla predicted that ere long great surges of electrical energy based on this work would soon usher from the Great Waterfall. These next series of experiments are shown with some reluctance, yet forced there to by the desire to gratify those who had shown such interest and formed so large an audience. I see I have little choice. Charging my body with electricity from an apparatus which I have devised, I can make the electricity vibrate at the rate of 1,000,000 times a second.
The molecules of the air are then violently agitated, so violently that they become luminous, and streams of light then come out from the hand.
In the same manner, I am able to take in the hand a bulb of glass filled with certain substances, and make them spring into light.
I had the pleasure of performing these very experiments privately before Lord Rayleigh, and I will always remember this distinguished scientist trembling in eagerness and excitement when he witnessed them.
The appreciation I have received from such a distinguished scientist as he has repaid me fully for the pains to which I have worked to achieve these ends. Tesla thereupon turned to the coil and announced that due to the enormous potentials about to be generated, He had constructed the machine with hard rubber insulation, as even dry wood is by far too poor for protection. Ino approached the free terminal with a metallic object held in my hand, this simply to avoid burns. The sparks cease when the metal touches the wire.
My arm is now traversed by a power fuel electric current, vibrating at about 1,000,000 times a second.
All around me the electrostatic force is felt, and the molecules and particles of dust flying about are acted upon and are hammering violently against my body. So great is this agitation of the particles, that when the lights are turned out, you may see streams of feeble light appear on some parts of my body.
When such a streamer breaks out, it produces a sensation like the pricking of a needle.
Were the potential sufficiently high and the frequency low, the skin would probably be ruptured under the tremendous strain, and the blood would rush out with great force in the form of a fine spray. Extending his fingers like a preening peacock, the electric sorcerer issued flames of lightning as if were Thor himself. The streamers offer no particular inconvenience, he assured the audience, except that in the ends of the fingertips a burning sensation is felt.
With his coil still charged and flames still shooting from his head, a number of other effects were displayed, including the running of motors by way of energy through his body and the lighting of a variety of colorful tubes, which the inventor waved about as if they were phosphorescent rapiers. His finale included the stretching of a series of long cotton strings across the stage, which he zapped with a pencil-lined corona of violet that etched a dazzling glow along its length, illuminating the stage in an eerie iridescence. Shouts of bravo accompanied the thunderous applause as the lecturer bowed again and again in response.
Shimmering from after effects and still emitting ethereal flames and fine halos of splintered light after the lecture, Tesla was called to the lobby so that he could be greeted by many members of the admiring public. So great was the desire to see Mr. Tesla closer that several hundreds of the leading citizens seized the opportunity and Mr. Tesla's hand in a very vigorous manner.
Upon his return to New York, Tesla completed his citizenship requirements. No longer would his patent applications refer to him as a subject of the Emperor of Austria, but rather as a citizen of the United States.
This was a proud moment. He would keep these papers safely stored away in a vault in his room for the rest of his life. Now a full American, Tesla decided once and for all to take on the mighty icon Thomas Edison.
Setting up one of his most provocative experiments, the upstart attacked head on Edison's carbon filament lamp, taking two identical bulbs, one filled with air and the other containing a vacuum, and attaching to it a current vibrating about 1,000,000 times a second. Tesla demonstrated that the lamp filled with ordinary air did not glow, but the one with the vacuum glowed brightly.
This showed the great importance of the rarefied gas in the heating of the conductor, and furthermore, the new light was cool to the touch. Brazenly, Tesla could conclude, in incandescent lighting, a high-resistance filament.
Edison's invention does not at all constitute the really essential element of illumination.
Taking the same two bulbs, Tesla then lowered the frequency, converted it to DC, and showed that the filament in the non-exhausted bulb now began to glow, though not as intensely as the other. He concluded that with DC the filament was the essential component, with high-frequency AC, the atmosphere around the filament, and thus the vacuum, was paramount. The higher the frequency, the more efficient the illuminant.
In fact, he noted, if DC were abandoned altogether and extremely high frequencies used, there would be no need for a filament at all.
Edison became perturbed not only because he had sent men to the Orient, Central America, and the Amazon in order to find the perfect filament, but also because one or two of them died in the quest.
That pompous Serb was not only saying that AC was intrinsic to the development of any practical lighting system, he was also proclaiming that Edison's most famous work would eventually be for naught.
End of Nikola Tesla, The Electric Sorcerer. Part 1. Thank you for watching.